Hello, welcome to section 4.2. We're going to talk about arithmetic and geometric sequences. Actually, this covers 4.1 and 4.2. So we'll actually start talking about patterns first, and then we'll move into arithmetic sequences, and then geometric sequences, and kind of get a little mix of both of them. So yeah, let's just start talking about patterns right away. So this is a sequence. It's what we would call a finite sequence in this example because there's no pattern that keeps going on after this. Usually what you'll see is a bunch of numbers separated by commas, and then if it has a little dot 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 after it, that means that it would keep going on. So since this pattern just stops after this, we would call this finite. So first thing, it says describe the pattern. So notice what's going on. We have a base of 2 of these little dots here, and then there's 3, and then there's 4, and then so on and so forth. You can also even look at the height of it. It starts adding 1 to the top, then it looks like it adds another one. But let's count the pattern, or let's count the dots and see. So this one has 3. 1, 2, 3, 4, 5, 6. And then if you count this one, it's 4, 5, 6, 7, 8, 9, 10. So this is what the pattern ends up looking like. So we added 3, and then looks like they added 4 more. And if you look at it, it's like they're adding 1 more whole slant diagonally. So it says draw the next 2 figures in the pattern. So if this one had 2 across the bottom, this has 3, this has 4. So this one, the next one would have 5 across the bottom, and then it would have 4 above it, and 3 above that, and then 2, and then 1. So it actually ends up adding an entire row of 5 more of these. So this pattern has 15 little dots in it. And then if we were to draw the one after that, we would have to add in another 6. So if you think about it, we added 4 here, then we added, we added 3, and then we added 4, and then we added 5. So the next figure would have 21. And again, I could draw that out. We would have 1, 2, 3, 4, 5, 6, and then 5 above that, so that's 11, plus 4 more is 15, add 3 more, it's 18, 19, 20, and 21. It's an ugly drawing, but it works. So again, that's just showing what patterns look like. That one we'll talk about is going to neither be geometric or arithmetic. And that's what we're going to talk about in this next part here. So it says describe each given sequence using the terms arithmetic sequence, common difference, geometric sequence, and common ratio. So I'll just take a second to talk about what those mean. An arithmetic sequence would be something that looks like this. If I were to count by 2 starting with the number 1, I'm just adding 2 every time. 1, 3, 5, 7, 9. So these are just all the odd numbers. If I put the little dot 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 there, that means it's going to be infinite. If I didn't have that, it would be finite. So this is an infinite sequence. It's arithmetic because what you can see is happening every time is I'm adding the same amount. And that's what we talked about as more like a linear type of function where you're adding the constant amount every time. So that's what's going to make this an arithmetic sequence. And that adding 2 every time would be what's called a common difference. And we use the word difference, which means subtraction. So why would I use subtraction here in this case? Well, in order to find it, what you're going to do is take the second number minus the first number. 3 minus 1 would mean I have a common difference of 2. If I take 9, subtract the term before it, 9 minus 7, also means that my common difference is 2. So you would always want to take a term and subtract the one before it to figure out what the common difference is. If a sequence is geometric, it would be something like this. So again, this would be an infinite because the dot 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 there, the little ellipses. But also just take a look at, I'm adding 2, and then I'm adding 4, and then I'm adding 8. So we wouldn't want to say that we're adding here. So it looks like we are also just multiplying. So it looks like I'm multiplying by 2, multiplying by 2 again. So since I have the same thing that I'm multiplying by, we call this the common ratio. And that's what makes this a geometric sequence. So in order to find the common ratio, what you're going to do is take the second number divided by the one before it. So if I were to take 16 divided by 8, you would get 2. And then if you wanted to keep moving to the right, you would use multiplication. So what we're going to do in these couple examples that are to the left here is determine if they are arithmetic, geometric, we're going to talk about what common ratio is, common difference. So this first one, notice it's 10, 20, 30, 40, and then it'd be 50, 60, 70. It would keep going. So what's going on here? Are we multiplying? Are we adding? It looks like we're adding the same amount every time. So that amount that we are adding then every time would be 10. So you would say that your common difference is 10. My first term was also 10, ironically. And then this is also an arithmetic sequence. So since we have a common difference in that we're adding the same amount every time, it makes it an arithmetic sequence. This one below looks like you would be adding 1, then all of a sudden you're adding 2, adding 4. So it's not adding the same amount every time. So this one would have to be geometric if it works out by multiplication. So it looks like we're timesing by 2 every time. So since you're timesing by 2, that means your common ratio is 2. And then that also makes it a geometric sequence. So if you are using multiplication and division, it's geometric. If you're using addition and subtraction, it's arithmetic. So then what we're going to do is use the common difference in these 3 cases, because we are talking about arithmetic sequences, and we're going to find the next 3 terms. So they're already telling us in the directions that these are arithmetic sequences. So if I want to find the common difference, I want you to take the second number and subtract the first number, and that's going to tell us what we're adding by every time. So 16.5 minus 12 is 4.5. And then if you were to take 21 minus 16.5, you would also get the same thing. So since our numbers are increasing here, your common difference is 4.5. So what you would want to do is take 25.5, and we're going to add 4.5 every time to that. So my next term would be 30. And then after that, again, you're going to add another 4.5, so then your next term is 34.5. And then you do it one more time, and we get 39. All right, next example. Same thing you want to do first. To find the common difference, take your second number minus your first number. So if I take 75 minus 90, I get a common difference, which we're going to use the letter D. And my common difference here is negative 15. So notice that the numbers are going down, they are decreasing, and that's why your common difference is a negative. So it makes the numbers decrease. So if I want to find what my next 3 terms are, you're still going to add the common difference. So I don't want to say that I'm just subtracting 15, but rather you're adding negative 15. You're adding the common difference. So then my next term would end up being 30, and then we would have 15, and then 0. So last one, I have some ugly decimals, but notice we're increasing here, so my common difference is going to be a positive number. In order to find it again, we're going to take 5.1 minus 3.8, and I get a common difference of 1.3. And again, you can take any 2 numbers and just subtract them if they're next to each other, consecutive terms. So if I were to take 7.7 minus 6.4, you would still get the same 1.3. So then moving to the right, what you're going to want to do is take the 7.7 and add 1.3, and you're going to get 9. And I'm going to add another 1.3 to that and get 10.3, and then 11.6. So those ones are the arithmetic sequences. Now we'll move on to geometric sequences. So with these ones, we're not going to have a common difference, but instead we're going to have a common ratio. So in this first one, to figure out what the common ratio is, you're going to take the second number divided by the first number. So if you take 0.4 divided by 0.1, you're going to get a common ratio of 4. So what that means is you are actually multiplying by 4 every time. So in order to figure out what my next term is, I'm going to need to take 6.4 times 4, and I get 25.6, and then keep multiplying by 4. So it looks like the geometric sequences are going to be the ones that are going to grow a lot faster because you're multiplying. So those would be the next 3 terms of that sequence. The next one, notice it has some negatives in here. It looks like every other term. So let's figure out why that is. So if I take my second term divided by my first term, negative 10 divided by 5 means that my common ratio, the letter R, is going to be negative 2. So what that means we're doing is multiplying by negative 2 every time. So let's take a look what happens here. We're off at a negative number right now. When you take a negative 40 times negative 2, you're going to get positive 80. But now if I take a positive 80 and multiply it by negative 2, I get negative 160. So what's happening is whenever you have another negative times a negative, it turns your sequence back positive. But then since your common ratio is negative, it'll turn it back negative again. So it's going to keep alternating back and forth between positive and negative numbers. So then this last one, you're going to take 160 times, negative 160 times negative 2, and we would get a positive 320. And then the last one here on the bottom, notice the numbers are decreasing, so they're getting smaller. So we're still going to find the common ratio the same way. I'm going to take 256 divided by 512, and I get a common ratio of 0.5. So what that means you're doing is you're multiplying by a half. Most people would say that you're dividing by 2, but again, since we're using the term common ratio, I want to keep multiplying by that common ratio. So if you take 64 times 0.5, you would get 32. Times that by 0.5, you get 16, and then multiply again by a half, and you get 8. So that's just using arithmetic and geometric sequences. The ones after this, what we're going to do is kind of a mixture of both of these. And we're going to throw in here what happens if it could be neither as well. So if there's no common difference or no common ratio, there still could be a pattern, but it would just be neither. So let me give you an example of that. I'm going to go back to the first pattern that we did here. Notice that I'm adding 3, and then I'm adding 4, adding 5, adding 6, adding 7. So there is a pattern, but it's not the same amount that we're adding every time, and we're definitely not multiplying. So this sequence that's on this first slide here is a neither, neither arithmetic nor geometric. So that might be one of our options here. Let's check this first sequence. So the first thing that I am going to check for is arithmetic. So if you take 8 minus 4, you get 4. If you take 12 minus 8, you get 4. If you take 16 minus 12, you also get 4. So since I'm doing subtraction there, and my numbers are increasing going to the right, it means that we are adding a common difference of 4. So that means that the sequence is arithmetic. And then it wants us to find the next 3 terms of the sequence. So if I want to keep moving to the right on this, I'm going to have to keep adding 4 every time. So my next term would be 20, and then 24, and then 28. Next problem then, notice we're alternating back and forth between positives and negatives. So it doesn't look like it would be arithmetic. It does not look like I'm adding the same amount every time, because if we were adding the same amount, it would keep going positive or it would keep going negative. It wouldn't keep going back and forth between them. So what I'll do is check for geometric. I'm going to take negative 18 divided by 9, and that's negative 2. And if I take 36 divided by negative 18, I also get negative 2. So if I'm dividing by going to the left, that means I would multiply going to the right, and that my common ratio is negative 2. So that makes it geometric since I have a common ratio. It's something that we're multiplying by. In order to figure out your next terms, I'm going to take negative 72 times negative 2, and that's going to give me 144. And then I'm going to want to multiply that by negative 2, and that gives me negative 288. And then one more time would give me 576. So then the last couple problems here. With this one, notice the numbers are increasing here. Let's check for arithmetic first. So I'm going to take 4 minus 2, which is 2, and then 7 minus 4 is 3, 11 minus 7 is 4. So I can see a pattern here, but it's not arithmetic because I'm not increasing by the same amount every time. It's not like we're adding 2 every time, or adding 3, or adding 4 every time. It keeps increasing. So let's check geometric. If I take 4 divided by 2, that's 2, but if I take 7 divided by 4, that's not 2. So this is not arithmetic and it's not geometric. So this one is going to be neither. Again, there's no common difference, there's no common ratio, but notice again, I'm adding 2, I'm adding 3, I'm adding 4. So if I wanted to figure out my next 3 terms, what I would do next is add 5. So 11 plus the 5 then would be 16. And then I would have to add 6 more, and that would give me 22. And then I would add 7 more, and that would give me 29. So that's what a neither would look like. There's no constant amount that we're adding by, and there's no constant amount that we're multiplying by. So that one is neither. And then this last one, let's check arithmetic on this first. Take 5.6 minus 9.8, and that's going to give me negative 4.2. I'm going to take 1.4 minus 5.6, and that's also going to give me negative 4.2. And then I could even do that one more time if I wanted to, but it already looks like it's arithmetic. And this last one comes out to negative 4.2. So notice my numbers are decreasing here. It's because we are adding a negative to our terms. So what I would want to do after this is take negative 2.8 and add another negative 4.2, and that's going to give me my next term, which is negative 7. And then I'm going to add again to that another common difference of negative 4.2, and that's going to give me negative 11.2. And then if I do it one more time, I get negative 15.4. So just to recap this, talking about arithmetic and geometric sequences, if something was arithmetic, we would be adding the same amount every time that we called a common difference. If something was geometric, you would be multiplying by the same amount every time, and we called that the common ratio. And if it was not arithmetic, not geometric, we would just say it is neither.